Good afternoon. Today's subject will be our subject ECE 6203, Electronics 2, Electronic Circuit Analysis and Design. Today's topic will be Power Supply Circuits. Okay, good afternoon. I'm Royalty from Engineering Department from Makati. Good afternoon. Okay, let's start. Today's topic will be covered the discussion about the power supply subsystem, the half-wave rectifier. It includes also the transformer, then the bridge rectifier. Then we'll also have some application or principle of a power supply filtering and the peak inverse voltage. Okay, let's start. Let's start with the definition of a power supply. All electronic products and equipment and system have a power supply. Then the power supply is the main subsystem that makes the rest of the circuits and equipment work. Okay, yung sa power supply kasi is ginagamit natin to para gumana yung, for example, isang circuits or some electronic components or equipment. Then we also have electronic products ginagamit din natin. Then sa equipment, system, then lahat ng mga ito is ginagamitan ng power supply. Then the power supply is a collection of components and circuits that supply one or more DC voltages to the circuits. Okay, yun yung definition ng power supply is collection of components and circuits that supply one or more DC voltages to the circuits. Okay, next. Then now we will discuss the types of power supply. Okay, ito yung mga types ng power supply or components katulad ng battery with a battery charger. Pwedeng ganyan ng power supply. Then pwede rin naman ng power supplies. Also, AC operated power supply. Pwede rin yan. Then power supply also include a high frequency AC or alternating current. Okay, yan yung power supply included. Okay, then next. Ang mga power supply also, as the main power source is the AC 120 volts, 60 Hz. Okay, usually yung power supply natin na ginagamit or main power source nito is nanggagaling sa AC 120 volts, 60 Hz. Okay, constant na yan yung sa mga ginagamit nating saksakan or socket. Then the input voltage is also filter to prevent high frequency spikes and noise and to block high frequency signals. Okay, ito yung function ng power supply is yung input voltage dito na pumapasok sa power supply is pinifilter to prevent high frequency spikes. Okay, may iwasan yung high frequency spikes tsaka yung mga noise na nagkakos ng interference sa ating main power source or input voltage. And also to block high frequency signals. Okay, that is the application or the function of a power supply. Then sa power supply also, it filter AC supply to a transformer. Okay, pinifilter din ng power supply yung filter the AC. Then isusupply ito sa transformer. Ang transformer kasi is pwede siyang step down or step up. Depende sa type or sa function. Katulad dito, the filter AC is supplied to a transformer to step up or step down the voltage. Okay? Then next, we have the rectifier. A rectifier is convert a sine wave or AC into a DC pulses at a 60 Hz rate. Okay, yung ginagawa ng rectifier. Sa power supply, it is included in the power supply. Rectifier converts a AC or sine wave into a DC pulses at a 60 Hz rate. Okay, next. So power supply also, after ng rectifier, since na-convert na to AC, from AC sine wave into a DC pulses at a 60 Hz rate, after ng rectifier is meron na tayong DC pulses are passed to a filter which smoothes the pulses into a constant DC voltage. Okay, after nung rectifiers, meron na tayong dadaan naman ito sa it will pass to a filter. Katulad ng mga, for example, kung ang smoothing components is capacitor, dadaan ito sa capacitor, then the pulses into a constant DC voltage. Magiging constant DC voltage na to. Then, this output na constant DC voltage can be used for some application. In most application, this DC voltage is further processed with a regulator circuit. Since ang lumabas na output na is constant DC voltage after gumamit ng smooth capacitor or smoothing capacitor, is pwede na natin gamitin ito sa mga application. Pero, kailangan pa rin naman, since yung mga ibang electronic components or system or equipment is hindi pa rin compatible or hindi pa rin suitable yung nakuha na constant DC voltage or naging output, is ginagamitan pa rin natin ng regulator circuits. Okay, kaya in most application, this DC voltage is further processed with a regulator circuits. Then many power supplies generate multiple DC voltage. Okay, yun yung function din ng power supply. May mga power supply na kaya mag-generate ng multiple DC voltages. Okay, then these multiple DC voltages are produced from the main filter DC using a multiple regulator or with DC to DC converter. Okay, para magkameron ng multiple DC voltages na napoproduce sa mga main filter DC, gumagamit din tayo ng mga madaming multiple regulators or pwede rin namang DC to DC converters. Okay, next. Okay, now we will discuss half-wave rectifier. Okay, as you can see, half-wave rectifier has a diode in series with the load resistor. Okay, yun yung schematic circuits ng half-wave rectifier. Then, half-wave rectifier also has a voltage that has ang magiging output ng voltage natin dito is a half-wave output. Okay, these are the schematic symbol or diagram for half-wave rectifier. Okay, makikita natin sa left is meron tayong AC na sinusoidal waveform. Okay, yan yung voltage input. Then, nakikita natin sa gitna is meron na tayong rectifier that will convert it to the output that is a half-wave rectifier. Okay, nakita na natin yung output nito that is half-wave rectifier na. Yung nasa right side, nakita natin is nakat yung negative alternation or nawala yung negative portion. Okay, ng sinusoidal waveform. Okay, that is the input to half-wave rectifier. Then B natin is yung circuits. Then yung C is yung sa right side, yung pinaka-output of half-wave rectifier. Okay, next. Okay, let's continue the continuation for a half-wave rectifier. A half-wave rectifier signals, then it consists of a DC value of the output is the average value. Then ang formula natin sa half-wave rectifier signal is DC or direct current voltage equivalent to BP or peak voltage over yung P natin na value ng voltage. Okay? Then the frequency output is or F out equivalent to F in, wherein frequency output is also equal to input frequency. Then we have the second approximation. Ang formula nito is BP out or output peak voltage is equals to input peak voltage natin bawas minus 0.7 volts or yung minus ng barrier potential na 0.7 volts. Okay? That is second approximation formula. Now we will discuss the block diagram or the components of a power supply. Okay? There are many types of a power supply. Most are designed to convert high voltage AC mains electricity to a suitable low voltage supply for electronic circuits and other devices. Okay, yun yung pinaka-function ng power supply is naka-design ito para i-convert yung high voltage AC main natin na electricity yung ginagamit natin sa mga saksakan or sa socket. Then para maging itong suitable to a low voltage supply for electronic circuits and other devices. A power supply can be broken down into a series of blocks, each of which perform a particular function. Okay, ito na yung mga block diagram ng power supply. We will discuss it later. Okay, ito na yan. Okay, for example, meron tayong 5 volts regulated power supply. Okay, makikita natin sa block diagram. Magsisimula muna tayo sa the block diagram of regulated power supply system. It consists of, magsisimula tayo sa transformer. Then, ang input natin is meron tayong 230 volts AC main, for example. Then, dadaan sa transformer. Then, it will pass again next to the rectifier that will convert AC to DC. Dito sa transformer is pwedeng maging step up or step down, ibababa or itataas yung voltage. Then sa smoothing is, meron tayong capacitor, then we have the regulator. Then the output will be the regulated 5 volts DC. Okay, let's start with the definition of this block diagram. Okay, first we start with the transformers. As I said before, ang transformer can be step down or step up. Katulad dito, step down, it means step down high voltage AC mains to a low voltage AC. Okay? Okay, then that is transformer, the first block diagram. Kung step up naman, ibig sabihin, i-step up niya yung high voltage or itataas niya yung value ng step up ng voltage AC main to a high voltage AC. Okay, mas mataas na value. Katulad naman sa pangalawang block diagram is yung rectifier. Ano bang ginagawa ng rectifier? Sa rectifier, it converts AC to DC. Kung alternating current natin, convert to direct current or DC. But the DC output is varying. Nagbabari pa rin yung DC output pagdating sa rectifier. Okay, yung pangatlong block diagram ng regulated power supply system is yung smoothing. Sa smoothing kasi, ang ginagawa nito, for example, yung capacitor, it smooths the DC from varying greatly to a small ripple. Okay, gagawin niya lang, i-smooth niya yung DC na output from varying greatly to a small ripple. Then pagdating naman is yung pinakahuli na part ng block diagram is yung regulator. Sa regulator, it eliminates ripple by setting a DC output to a fixed voltage. Okay, yun yung ginagawa ng regulator. Okay, another continuation of the power supply block diagram or yung mga parts. Okay, for example, meron tayong transformer. Dito sa umpisa, is meron tayong input ng high voltage AC, main supply. Okay, dyan dadaan. That is the primary. Then pagdating sa secondary, is nandito na yung output ng tinatawag nating low voltage AC. Okay, sa transformer. Okay, ito yung schematic symbol niya or diagram. Makikita natin yung output is low voltage AC pa rin. Mas mababang value ng low voltage AC than the voltage and the time. Okay, next. The low voltage AC output is suitable for lamps, heater, and special AC motor. Okay, yung dito yung dumaan sa transformer is meron tayo ng output na low voltage AC. Is pwede natin siyang gamitin sa mga lamps, heater, and special AC motor. But it is not suitable for electronic circuits. Okay, hindi pa rin naman suitable or hindi natin pwedeng gamitin since gumamit na tayo ng transformer para sa mga electronic circuits. Pwede lang natin siya magamit sa mga electronic circuits kung mag-i-include tayo ng rectifier at saka smoothing capacitor. Okay, that means the rectifiers will convert AC to DC. Then kapag yung smoothing capacitor naman is, ang gagawin nito is smooths the DC from varying greatly to a small ripple. Okay? Then yung pinaka-last part, katulad natin na-discuss natin kanina dito is regulator. It eliminates the ripple by setting a DC output to a fixed voltage. Okay, katulad ng regulator is yung pinaka-common na ginagamit natin na LM7805 voltage regulator IC, wherein ang output voltage natin is lalabas na 5 volts, tsaka yung current naman natin is nasa 1.5 amperes. Okay? Okay, these are the review or the regulated DC output. It's very smooth with no ripple. It is suitable for all electronic circuits. Okay, ito yung example na block diagram or schematic diagram for power supply. Wherein sa una, meron tayong transformer, wherein these are the AC mains. And then dito makikita natin yung output voltage or AC voltage na low. Then meron tayo ng bridge type or naka-rectifier that will convert AC to DC. Then meron tayong smoothing component na capacitor that smooths the DC from varying greatly to a small ripple. Then yung pinaka-last, yung regulator, katulad na pinaka-common is yung LM7805, is it eliminates the ripple by setting DC output to a fixed voltage. Okay, that is the block diagram or the schematic diagram for power supply. Okay, ito na yung output na makikita natin. The regulated DC. Okay, regulated na siya. Ito.